Here we're going to look specifically at simplifying rational exponents. So simplifying rational exponents, we have a rule that we need to follow, and we've got different versions of the way that rule looks. So a rational exponent is simply an exponent that's a fraction. So if you look at these, notice a to the 1 over n, this is a fraction form. And what it means is that the numerator, okay, so your numerator here would be your power, and your denominator here is the root. And so that's going to be the same no matter what your fraction is, that the numerator is always your power, the denominator is always your root. Now that being said, we do have a most common way that you see the rule, and that is like this, where you have an actual number other than 1 for both your numerator and denominator. And with this common rule, we have two versions. The version that we use if we do not have any variables, and the version we use if we do have variables. So you need to make sure you keep these two rules separated and straightforward, because they have to be applied correctly when solving. Okay. So I've got some examples here that we're just going to start working through, that hopefully by the end you should feel fairly confident at simplifying these rationals. So let's look at this first one. I have 16 to the negative 3/4. So the very first thing you always want to do is you want to identify what is your power and what is your root. So here the negative 3 is going to be my power, and the 4 right here is going to be the root. Okay. So with that, we're going to set it up. Now notice there are no variables here, so we are going to use the no variable version, which is this first one here. And so what we have is that we're going to work with the radical first. So my root is 4, so this is going to be the 4th root of 16. And then we're going to take that and we are going to raise it to the negative 3. Okay? So we have the root structure inside, and the power. So the first thing we're going to do is we are going to evaluate the radical on the inside. So you want to go think back to the radical rules that you have to being able to reduce this. So one of the things that we know is that 16 is the same as 2 to the 4th. And of course this is still surrounded by my negative 3. And then one of the things we know is that if your power and your root are the same, they cancel each other out. So this simply becomes 2. And I'm going to take this to the negative 3. Now, one of the things that we now have here is we have to fix the negative. And so what that means again is we have to flip it, and then we're going to change the sign. So here what this is going to become is this is going to become 1 over 2 cubed. And 2 cubed is 8. So the overall result here is actually 1 over 8. Okay? And so notice again, we started with your power and your root. We had to use the form where we did not have any variables. Okay? Alright, let's look at this next one. So over here, notice we do have variables, and we don't just have one, we have 2 of them. But the biggest thing you want to look at is the fact that each of these roots is exactly the same. So in this case, when we're looking at it, the first thing that we need to do is we need to rewrite using radicals. Okay? And then after we do that, we want to simplify. So that's the goals that we're looking at right now. So the first thing we have to do again is identify your power. And so here we've got 2 powers. So the first power we have is this one, which is your power. But then it's also the 6. Going with that, we've got the 5 right here, which is my root, and it's the same as the other one, which is the 5. So here we're going to start it out. We're going to use the variables version. So this is going to give us the 5th root of m to the 11th n to the 6th. So here what we have to do is we have to separate each of them. So again, you're going to use your radical rules to separate them. So if we were to look at just m to the 11th, okay, in order to reduce that down, I have a 5 on the outside. And so here I would use old school division. So I'm going to have 5 and I'm going to divide that into 11. So when I do that, 5 can go into 11 twice, which means minus 10, leaves me with 1. So there's a few things that this tells us. First, this is how many we pull out. So 2 pulls out, and the 1 is how many we leave in. 1's left in. We can do that exact same thing again with the 6. And so here I would have my 6 with the 5 on the outside. So 5 can go into 6 one time. When we subtract the 5, it leaves a 1 behind. So just like before, we would pull one of them out and leave one of them in. So what am I talking about? I am talking about, if we come back up to my first one, this was doing with my m's. So I'm going to pull out 2 m's. So this is m squared. I then have to pull out one of my n's. So I'm going to pull out one of my n's. I still have the 5th root for my radical. Going back to my m's, I'm going to leave one of them in. So this is m stays in. Down to my n's, I'm going to leave one of those in. So an n stays in. And this is the overall result. Alright, so let's look at some different ideas behind them. So first of all, we might have questions where we want to simply convert the radical into exponential notation. So to do that says that we have to apply the rule. And so here, the rule again that we are looking at is that we are using the variable. So the rule that we have is that n to the a to the m, so the nth root of a to the m is going to be the exact same as a to the m divided by n. Okay. So again, we have to identify your power and we have to identify that root. And so here it's fairly simple. If we look at this, right here we have a power. And my index is going to be your root. And so all we simply have to do is just rewrite it. And so here we're going to end up with y. We're going to have our power, which is 4, over our root, which is 12. Once we do this, the biggest thing we have to do is we have to reduce your fraction using fraction rules. So here what we know is that if we have 4 divided by 12, well, this is the same thing as having 1 over 3. So we're going to go ahead and reduce everything down, and what happens is we end up with y to the 1/3. And that is going to be our reduced or overall solution. Now with the second one, notice I have 2 roots. Okay, and so here the first thing that we have to do is we need to remove the roots to rewrite. Okay, so we are going to remove the roots. And in this case, what we're doing is we are going to rewrite the equation. Okay, so if we look at this first one here, the first one is telling me that I have 2 to the first power, and it's a square root. Okay, so let's take a look at that. This is really saying that I have the square root of 2 to the first. And then I'm multiplying this by the cubed root of 2 to the first. So if we identify our pieces, again, what we have is that this 1 right here is a power, and the 2 right here is a root. So when we do that, this is going to tell me that I have 2 raised to the 1/2, and I'm going to multiply that by the same thing over here. So again, the 1 is a power, the 3 is a root, so this is going to be 2 to the 1/3. We have to then use the product rule, so this is now your product. And the product rule says that we have to add the powers. So when we do that, what we're actually doing is we are going to take 1/2 plus 1/3. Using our fraction rules, what's going to happen is we need a common denominator. So here 1/2 is going to become 3 over 6 plus 2 over 6, which gives me 5 over 6 as a result. So therefore, what this really and truly means is that I have 2 to the 5/6 power. Alright, let's make things a little bit more complicated. So first of all, I have my 2, and I want to write it in radical notation. So I want to take it from fractional powers down into a radical. So the first thing that you want to do is you want to simplify first. Then, after you simplify, we want to rewrite the fractional powers as radicals. Okay, so those are the two things that we are doing. So let's go ahead and get started. So the first thing we have to do to simplify is we need to recall that this is going to use the power rule. Okay, so here we are going to use that power rule, which says we have to add the powers. Okay, so here we're going to multiply our coefficients. So this is going to be 3 times 2. And then we're going to have our base, x, and we're going to have to add our powers. So 1/2 plus 2/3. So we need to go ahead and do that addition. So here we've got my 1/2 plus my 2/3. Again, I need a common denominator, so this is going to end up being 3 over 6 plus 4 over 6, which is going to give me 7 over 6. So with that, 2 times 3 is 6, so I really have 6x to the 7 over 6. Now I have to rewrite in terms of my radical. Okay, so here again it's about identifying. My top one right here is going to be my power. The bottom one right here is going to be the root. So what we actually end up getting is we end up getting 6, and then I have the 6th root of x to the 7th. Now that I have my radical form, I have to go ahead and reduce. Okay, so here I want to reduce, and I'm going to do that using old school division. So old school division again says that I'm going to take my power, so 7 goes inside the divider, my root goes on the outside, so 6 can go into 7 once, minus 6 leaves 1 behind. So just like before, this one tells you what is taken out, and this bottom one tells you what is left in the root. Okay. So here what's going to happen is 1 comes out, so I have 6x. I then have the 6th root of x. And this is my overall result. Alright, let's take a look at just a couple more examples here. Hopefully this will help. Each example, as you can see, is a little bit more complicated than the rest. So in this first one, again, the first thing that we need to do is we need to apply our rule. And so here, what we're going to do is we have to apply the quotient rule, which says that we have to subtract the powers. So we're going to do that for each. So notice that I have x and I've got 5/8 over x to the negative 3/8. So we're going to go ahead and start setting that up. So here I'm going to break it apart. I have x to the 5/8 over x to the negative 3/8, and then I have y to the 2/3 over y to the 1/4. Okay, so with that, we're going to use that division rule, which says the first term is going to be x to the 5/8 minus the negative 3/8, and then I'm going to have y to the 2/3 minus 1/4. So I'm going to actually do the math here. So I have 5/8 minus the negative 3/8. So negative and negative becomes positive. So in this case, we end up with 8 over 8, which gives me 1. And then we need to do the other. So I have 2/3 minus 1/4. I need a common denominator, which is 12. And so this is going to become 8 over 12 minus 3 over 12, which is going to leave me with 5 over 12. So when I rewrite my equations here, this is going to become x to the first power, y to the 5 over 12 power. Now with that, I have to use a radical, but I only have to do a radical on part of it. So this piece right here, I need to rewrite using a radical. And so here again, that means identifying the pieces. So just like before, my numerator here is going to be the power. My denominator here is going to be the root. And so in this case, we end up getting x to the 12th root of y to the 5th. And that is what we're looking for, this right here. There's nothing else I can do to simplify it, and so that's as far as we can go. Alright, let's look at this last one here. So one of the things to notice about this last one is that all of them share the same variable. So what it means is that we have a rule within a rule. So the first thing that we want to do is we want to use the product rule, which says I'm going to add my powers, and I'm looking specifically in the numerator. So here I'm going to take my numerator and rewrite it so that I have n to the negative 2/3 plus 5/8. And this whole thing is still over the denominator, which is n to the negative 1/4. So with that, I need to do the math here. So I'm going to do negative 2/3 plus my 5/8. I need to have a common denominator, which is 24. So here this is going to be negative 16 over 24 plus 15 over 24. And in this case, we're going to end up with negative 1 over 24. So when I rewrite my term, I'm going to end up with n to the negative 1 over 24 divided by n to the negative 1/4. Now with that, I now have to use my quotient rule. The quotient rule says I have to subtract the powers. And so here what's going to end up happening is that we are going to end up with n to the negative 1 over 24 minus negative 1 over 4. So just like before, I need to go ahead and do that math. So I have negative 1 over 24 minus a negative 1/4. So this is negative 1 over 24 plus 6 over 24, which is going to reduce to 5 over 24. So in this case, what we end up getting is n to the 5 over 24. And now we need to rewrite using radicals. So the last thing to do is to rewrite using your radicals. And so here again we're going to identify the numerator is my power, the denominator here is the root. So this is going to end up being the 24th radical of n to the 5th. And there you have it. That is everything that you need to know in order to get started using your rational exponent rules to simplify exponential problems. So if you have any questions, please let me know. Otherwise, I hope you enjoyed, and I'll see you next time.